All right. Welcome everyone to the dark mode. So when I've given talks about MEV in non-MEV specific context, I always start with some explanation of what MEV is. I have these slides with colorful emoji, or I have the dark forest. But here, I don't really think I need to explain MEV to you all. It's a pity. I like using these slides, but yeah, not needed here. Yet, I would say that we don't have a definition we all agree on around MEV. So this is a definition you already saw in Phil's talk. The definition in the OG Flashbots paper. It's MEV is the total amount of Ether miners, blah, blah, blah. So here you already have like one thing that stands out, Ether, right? There's MEV in other chains, so we know that. So this is already outdated, right? And miners in particular is going to be outdated soon. So perhaps another more recent definition goes, MEV is a measure of the profit a miner, but wait there, we're talking about profit, the other was more talking about value extracted, so revenue. So are we talking about profit? Are we including costs or not here in the definition? Another definition, this is from MEV Explore. MEV is a measure of the total value that can be extracted permissionlessly. We haven't been talking about that before. Is it permission? Is it permissionless? What are we talking about here? So these are subtle differences, right? But I'm taking all this. This is an OG paper. Second one is from MEV and Me by Charlie Noyes. Third one is from Flashbots MEV Explore. So all these are like what I would call mainstream definitions of MEV. If you venture like far out there, you have like statements like ARBs are not MEV. Yeah, I don't know what they had in mind here, really, what definition they have in mind in this case. But anyway, what I'm saying is like, it's to me apparent that we do not have yet a consensus on definition. And like, if you look at the acronym, even there's no consensus on what that means, right? It was minor extractable value. We rebranded it to maximal extractable value. So which is it? So, and this, I'm talking about the colloquial definitions, but if you want to answer research questions, important research questions as like, does this certain fair ordering protocol eliminate MEV, for instance, right? This question requires a formal definition, right? I want a theorem to, like, I want given protocol P that implies MEV equal to 0, right? For that, I need a formula for what MEV is. We don't have that right now, is my claim. Other questions that we're interested in is like which decentralized exchange design minimizes MEV exposure. Again, we need a formal definition for this, right? So we don't have like a colloquial one, much less we don't have like a formal one that we agree upon. But wait, we have data, right? We have this in MEV Explore. You want to explore, you see these numbers, $600 million extracted MEV, and we have plots about that, how that changes in time and so on. So what's going on here? Like computers still prefer symbols to natural language, right? So there's something, certainly a formula we're plugging in there to compute that. And yeah, certainly enough, if you plug in, if you hover with the mouse, you see that I there and you click on it and there's like extracted MEV includes successful MEV transactions without so anyway, that's like an attempt of an explanation of what that number is. Then there's like a data page there that you can go, and certainly enough, there's like the formulas there, but I'm not sure if all of you have checked those formulas. I'm not sure if all of you would agree in that those formulas up there are what you think about when you think about MEV, right? So anyway, there's, again, several things one can talk about when talking about MEV. And so in this talk, what I will attempt to do is convince you that there's no consensus around what MEV is, in particular a formal version of it, and try to give you a few pointers of why it's difficult to get a consistent definition of MEV, or what are the caveats one has to take into account to get to a definition, right? So first thing I'm going to do, I'm going to separate between two different concepts that we sometimes mix together. And these are the concept of MEV on the right hand as a theoretical entity. The extractable value, the total extractable value, that's a very much theoretical thing. It's the one we want to minimize, or like we want to talk about in these formal questions, like which decentralized exchange design minimizes MEV exposure. That's like the big set, unattainable, if you will, that we want to talk about in theory, right? But then on the left hand, we have this other quantity, the one more tied to the graphs I was showing you before, that I like to call realized extractable value. That's the actual value that's being extracted, right? What of that MEV is actually realized in extraction. This is a bottoms-up approach, right? We in MEV Explorer, if you look at the code behind that, that's MEV Inspect. There's like inspectors there, and okay, they look, they see an ARB, okay, they add up to the count. They look around, they see some liquidation, they add up to the count. Right? So this is like sort of growing set of value that we are taking into account, like expanding into this vast thing that's the theoretical extractable value that's out there. So I think it's important to make a difference between these two things, because again, when we saw the graph, we're calling that MEV, but that's very different from the theoretical notion of extractable in principle. So I'm going to talk a little bit about each of these. I'm going to start with the realized extractable value, a few words on that. So realized extractable value, think you have let's do some like schematics here. We have like a chain, right? And a P is a producer, miner now in proof of work, that's extracting value from the chain. So this is the simplest setting, right? There's an arrow of value flowing from the blockchain to the producer. So this could be thought of as, okay, is this blue arrow the realized extractable value? Perhaps, but we know that in practice the picture is a bit more complex, right? It's typically not the producers that, particularly with Flashbots, right? It's not the producers who extract MEV directly, but searchers who do the extracting. So there's searchers extracting MEV, and then searchers paying some cut of that MEV to producers, right? So there's a red arrow going from the chain to the searchers, and then some like red-blue arrow going from searchers to producers, right? This already makes the picture more complicated, because which is the realized extractable value? Is it the red arrow? Is it the sum? Is it the subtraction of the arrows? So you have to choose, right, and define it. If you dig a bit further, it's actually more complex, right? Producers are actually paying an opportunity cost to include like an MEV extracting transaction as opposed to a vanilla transaction from the mempool, right? So there's an arrow that's flowing out, right? So what do we do with this arrow again? Do we subtract it? Do we not? Again, more complex picture in actuality. If you think about priority gas auctions, there's other searchers, perhaps S prime, also trying to extract MEV and are fighting with S to get the opportunity, and they sometimes lose, so they don't get the MEV, but they still pay minor fees, right? So there's another arrow here flowing from searchers to producers. Should we include that? Should we not? Okay, so my approach here is to think about the total MEV activity in the network with three terms, right? There's the realized extractable value for the searchers, and these are the red arrows. So the arrows going in enter the equation with a plus sign, and the arrows going out enter the equation with a minus sign. So it will be the red arrow minus the red arrow going out for REVS. That's a realized extractable value for searchers. There's a realized extractable value for proposers. That's, again, arrow going in with a plus, arrow going out, the opportunity cost with a minus. And on all of that is the REV. And note that there's two arrows, the blue and red there, that cancel each other because they enter with different signs, right? So this is the total realized extractable value in this picture. And then there's a separate arrow that I choose not to include in realized extractable value that I call the extractable value cost. Note that this arrow is only there because there's MEV extraction going on, right? We have this process of MEV extraction, and that sort of yields this new activity that searchers paying miners for something they're not getting, right? So this green arrow only exists because there's extractions. So I don't think this is part of the actual extracted value, but it's an extra thing. And this is exactly what imposes a cost to the network, right? This is what penalizes users. This is what blows the chain. This is what raises gas fees. And this is what ultimately, I believe, Flashbots was successful in reducing, right? This this cost for the network. You know, this PGA now in Flashbots, if you use Flashbots, doesn't happen, right? So you don't have this extra arrow that's bad for the network, right? So anyway, if you're interested about this, I have like a write-up I did a while back, so I'm more than happy to discuss these ideas with anybody interested. Okay, so that's in the REV front. So now I'm gonna talk a little bit about MEV. So first, let me say that as Phil mentioned in his talk just now, there's no formal definition in the OG Flashbots 2.0 paper, which some of you might find surprising. So I'm going to start quoting the Clockwork Finance definition Phil already explained. Here it's rewritten a little bit to simplify notation, but conceptually it's the same, right? And I'm not going to dig too deep here because Phil already explained it. And essentially what you have to take out here is that it's a difference of balances, right? The extractable value essentially is a difference of balances that a certain player can attain by choosing a certain set of blocks, right? So Phil said, like, some people disagree that that's the definition, and probably referring to me, I disagree. I don't. I think there's problems with this definition, as there is with any definition out there, really. So what's the problem with this definition? Because again, it's tricky to get one definition that works. So to me, the main problem with this definition is the idea of player. So where P there in the equations above is a player. But in that paper, they don't like elaborate really on what a player is. And if you think of it, there's like at least 3 distinct notions of what a player could be. And so the first one is, and again, they're all intertwined, but I think they're distinct, and we have to clarify that a little bit further. So first possible meaning of player is a player as a transaction signer, right? An Ethereum signer with an address and some balance in it. Okay, so that's one meaning in which P can be a player. Second meaning is the player as an actor in the protocol game, a player like a node operator that has some stake and is validating and so on, and has ordering rights or doesn't have them in, like where it's their turn to propose or not. And third notion of player, it's a player as a node operator, right? A player as a peer-to-peer, part of a peer-to-peer network that has to think about latencies and so on. So this is yet another possible meaning. And again, these are all tangled together, but it's not explicit what are we talking about when we talk about that, and I think we have to make it explicit. So this is one problem. But more importantly, I think there's a problem with permissionless. Remember that idea in one of the definitions that MEV is a permissionless value. I think that's critical, right? To me, MEV is about the permissionless extraction. Because think about what would happen if a player here has a pending airdrop to claim, right? This definition of MEV would be very different for that player than for other players, simply because they can claim an airdrop and there's value for them there. So I don't think this is actually MEV. I don't think MEV is what we're talking about when we are thinking about a pending airdrop, right? So to me, we could use a notion of MEV that's permissionless, that talks about like what can any like player in the network actually extract, right? So anyway, I think this is a problem with this formulation, and I think we can do better and deal with the player better. So I'm gonna list a couple of other caveats. So I've talked about the player and the potential dependence on the player. I think that's something we have to think about deeper if we want a good definition of MEV. A second point is the treatment of reverted transactions. I touched upon this when I was talking about realized extractable value, right? We have like transactions that are reverted and are there only because of MEV extraction. How do we deal with those in the MEV definition? Do we include them? Do we not? Third one is transactions or blocks versus state transitions. Here, all the definitions we're talking about transactions and blocks. When we want to think about other domains like centralized exchanges, Phil mentioned this idea of like, okay, centralized exchanges might have a lot of MEV we don't know about. So, but they probably don't run on a blockchain, right? They have different type of databases. So perhaps we want to make a definition that's more flexible and that wants to do something more general than blocks and transactions. So perhaps we want to move to state transitions instead. Another point is the unit of account. Here I've been using implicitly the unit of account of the native domain, right? But as Phil mentioned, in the cross-domain, things get trickier, right? We have like different native units of account in each chain. We want to use pricing functions to map one to the other, right? And in particular, there's another thing here, that's a context dependency. How does the MEV in one domain change because there is MEV in a different domain? Because, or because even another domain is present there? This is a super important question. And yeah, there's going to be a talk by Alex soon on context dependency, so and cross-chain MEV in general. So I encourage you to check that. But this is a very important topic that we certainly want to cover in our MEV definitions. Another one is revenue versus cost. I already also touched upon this very briefly, but are we talking, is MEV a revenue, or are we also including the costs incurred in extracting this MEV? Is it the profit or the revenue, right? And one tricky thing here is that the revenue is typically thought of as the revenue in the scale of which you have extracting rights, right, in a block typically, whereas the cost one typically thinks about in unit of time, right? If you're a miner, you're not thinking how many dollars it costs me to mine a block, because there's like a stochastic dependence between two, right? Because there's a stochastic processing by which you get to mine a block. This is a random process. So typically you think of unit of time, how much does it cost for me to operate this rig per hour or something, right? So anyway, the fact that it's a stochastic process linking these two, it makes it a bit tricky, and again, another decision to make where we include that or not in the definition. Final consideration I have here is a single block versus multi-block, right? And these are like two different types of MEV. There's a reorderings and censoring the single block, but there's a reorgs in the multi-block, and that touches finality and so on. So what do we want? We want the definition to encompass two, but how do we deal with this? So for me, like the best way to deal with this is actually think of MEV as like have a definition of like given ordering rights. So we consider the ordering rights granted, and then we can think of the multi-block MEV as a distribution over these rights, right? It's independent of how you got those rights, and then you think about that as a separate question, right? I'm gonna explain that in a second. So with this, I will wrap up. I'll just, to be a bit more constructive, I will give you some more thought-provoking definition. I don't expect this definition to be the final MEV definition. There's certainly points that do not work, but just, again, food for thought. So this is the extractable value. Still depends on a player, and I'm talking about states as opposed to blocks. This is, I don't feel too strongly about this, but I think it might be good to have a more general definition. And again, it's essentially a difference in balances. We have the balance after the change of state, and that's what the player still P there wants to maximize, right? This is the extractable value, the maximum difference in balance they can achieve by changing the state. And here, the crucial part in this definition is that the player is an Ethereum signer or any chain signer that has granted ordering privileges, right? So in the definition here, I think, okay, we give the ordering privileges, and then what maximum value, and it doesn't matter. They might have the ordering rights because they're a proposer, they might have them because they bribe proposers, they might have them because they bought like mining rigs, whatever, right? I don't care. And then for the multi-chain, multi-block case, we simply average over like the probability of getting many blocks of averaging rights, depending on the process of how this player is getting those rights. But that's a sort of push aside. It's a separate problem. Let's separate the problem of how I got the ordering rights and the actual extraction, right? That's what I want quantified in the extractable value. So this is the extractable value. And finally, the miner extractable value is a formula where and this is the provocative part, because it's a maximum, but I take a minimum, right? And this minimum encodes the permissionless nature, right? By minimizing over players, I'm taking the MEV to be the extracted value that the least privileged actor in the network can get, right? And this is is certainly tricky, because say you have like a smart contract which censors some opaque addresses, right? So you for these opaque addresses, they won't be able to interact, right? Opaque censor addresses, so they won't be able to interact with the contract. So for this, the extractable value will be 0. Right, so the whole MEV will be 0 for that setting. And it's tricky, but it's like one approach with dealing with permissionless. And here, like one final comment is I reintroduced the player here, but this parameter K is the capital of the player, right? So I did not want to the MEV to depend on players, but I'm reintroducing a dependency in a parameterized way, right? Because we know that capital is a very important parameter in MEV activity, right? We in particular expect this definition to be monotonous on the amount of capital, right? The more capital a searcher has, the more MEV they will extract typically, or they will be able to extract. So that's why we want to include that. And choosing capital, again, is very much a choice, right? It's very much a design of what we think is important in MEV terms. If we just put a P there, it's vague, because, again, we don't know what we're talking about. So my approach here is like, okay, let's be deliberate. Let's choose how to model a player. Let's choose the parameters that are important for MEV and plug those in the formula, but only those, right? And of course, we leave out other things like, okay, if the player has ethical considerations and they feel like, okay, they don't feel like extracting some kind of MEV, okay, for them it will be different, right? But my claim is we should be explicit about those choices. So anyway, provocative definition, I don't expect this to be the final definition of MEV, but at least to sparkle some thoughts about the problems and the difficulties with arriving at a mutually consensual definitions. And I have a write-up of this too. Welcome to check it out and reach out for me for discussions. So that's all I had today. So thank you very much for tuning in.